Welcome to another data science deep dive on our technical track. In the following presentation, we have Rhonda Textor, head of data science at TrueFit. TrueFit believes that details matter, especially for modeling individual fashion preferences. Because of that, they have built the largest fashion and retail data set called the Fashion Genome. In this talk, Rhonda will share some insights they have gained from the Fashion Genome that have influenced their approach to building fashion recommendation systems. She will also show how they leverage the fashion details of products, i.e. their fashion attributes, to combine fashion and technology to make the best recommendations possible for the consumers. Finally, she will share how they leverage their large data sets and cutting-edge technology to enable personalized shopping experiences. Enjoy!
Hi everyone. So I want to start kind of with a little bit of a personal story about me and fashion and retail, and part of why I'm so excited to be here. So the very first talk that kicked us off, Divya from Levi's talked a lot about Levi's, and I was one of the people who raised my hand that I wear Levi's. When I was in high school, I got a job washing dishes so I could buy the jeans that the cool kids at school were wearing, the Levi's. And back then, it took like 8 hours of washing dishes to buy one pair of Levi's. And I'm excited to now be a data scientist because I can buy a lot more Levi's and other things. So I'm going to tell you a lot more about TrueFit and what TrueFit does, but it's a platform, works with a lot of retailers to help make consumer recommendations for online shopping. And so now I get to combine that passion for clothing and fashion with that passion for math and data science that draws on my computer science background. So I know some of you are aware of TrueFit. There are some retailers in here that are actually clients of TrueFit. Our mission is to help real people find clothes and shoes they love and keep. And I want to drill in on a few pieces of this mission statement. So the first is real people. This is not, say, the average person who is actually no one. We care about lots of different shapes and sizes. We care about lots of different preferences. One thing, when I'm hiring for someone on my team, I get asked, do I need to care about fashion, or do I need to know a lot about fashion? Certainly some people who use our tool and who shop online are really into fashion, but as you can see around you, pretty much everyone wears clothes. Everyone has to acquire those clothes somewhere, and so our mission is to help everyone find clothes that they want to wear. And second, the clothes and shoes piece. This is we think that there are some very specific things, and so a lot of this talk is going to be about technology and technology that's used to make recommendations. And I'm going to be talking about how we use our data to make those recommendations specific for clothes and shoes, because they're not just utilitarian. They have to fit on your body, which is different from all the other consumer goods that you purchase. And two, they say a lot and communicate a lot about who you are and how you want the world to see you. And we think that that's important. And then finally, the love and keep. This is the value proposition. So we charge money to retailers for our service, and that's because when people find things that they love, they purchase them, and then when they get the right size and when they get them and they find out that they love them, then they keep them, thus eliminating a big cost of doing business in retail in processing returns. So this is not going to surprise anyone here. What makes this problem harder, especially online? Well, the first problem is, it's great when we've moved online, there's a lot more inventory, right? We're not as limited in a physical store, but frequently if you show up on a retailer page, you get kind of this random hodgepodge of stuff, most of which might not be relevant to you, and the collection is not relevant to necessarily anyone. Here we have what's like a high heel, very dress shoe in the same list as like a camping shoe. And so this particular assortment of products probably isn't really relevant. Maybe we've all been fatigued when we see like the list that we have hundreds and hundreds of pages we can go through to find the thing that we're looking for. And many people, including Amazon, have done research that says most people don't click past the first page. So this is a problem. And then one of the big problems that TrueFit's been working on for a long time is this issue. Once I find something, so okay, these jeans look good. I would like these jeans. Now I'm trying to interpret lots of different and perhaps conflicting information on the page in order to figure out, is this going to fit me? This case, I'm US based. These are US waist size based women's jean sizes, so I understand them. But if I'm shopping somewhere that has sizes from, say, the UK or the EU or somewhere in Asia, that's going to be even more confusing. Oftentimes the reviews are conflicting or unhelpful. You don't know, are these people who couldn't fit in these jeans, do they have a similar body shape to me? Fortunately, and this is very relevant to this group, we've been talking about these things all day, there's a lot of technology out there to help with a lot of these problems. Statistical techniques, machine learning techniques, collaborative filters, neural networks are all being leveraged all over the place in retail. So here's an example from a particular paper. Again, we're all pretty familiar with the idea that we can find similar items using images. We can tell what's in an image. It's an amazing technology. Even 10 years ago, this was not something that I necessarily imagined would be solved to the degree that it is right now. I like to read books, and so certainly we see a lot of the because you like, you might also like recommendations. That's one of the ways that I find new books that I want to read. And we use some general techniques and statistical analysis to make some general predictions. So something like, hey, leopard print is going to continue to be huge. It is. But what's all of these methods have in common is that they all require data. And this is where TrueFit comes in. So I want to use this as an opportunity to tell you a little bit about TrueFit. So we've been working on building what we call the fashion genome. This is very similar to the music genome, or think of other big data sets on consumer preference data that are used to power recommenders. One thing that's important to know is that we work with hundreds of stores and thousands of brands. And so a lot of the presenters today have talked about how they manage their own inventory and as a single store. And they may have a really large catalog as one store, think, for example, Nordstrom. But we work with hundreds of stores, and so we have big stores, small stores, stores that sell only to women, stores that sell only shoes, stores that sell only athletic wear, and we're trying to make some general purpose tools that work and provide solutions for all of them. We get transactional data from all of these stores. So we have billions of transactions that we can learn from. And it's really interesting because then we have representation of preferences across all these different kinds of stores all over the world. Certainly in the United States, in Europe, in the UK, in Asian markets, and in Australia. And then we have our own registration process where shoppers register and tell us a little bit about themselves. And we have over 100 million shoppers who've used our platform. So altogether, this makes for a really interesting, diverse, fairly large data set to play with that's a lot of fun for me and my team. So I'm going to walk through and kind of show how the data that we have enriches this basic transactional data and how that enables us to learn some pretty cool trends. So hopefully I'll show you some data analyses that we've done that hopefully you haven't seen before or not exactly this. And then going to show you how we leverage some of this to do some predictions, to make some consumer-facing recommendations. And then this is research so I run the data science team. We're very research focused. Some of our research does make it into our consumer-facing products, and certainly some of what I'll show you is in those products, but kind of show you how we're thinking that this all comes together to then make that initial shopping experience easier that we kind of talked at the beginning. So first, just again, this is very retail focused. You guys are probably very familiar with this, but I just want to start with this baseline that often the information that you have is a data set that has identifiers and maybe something like a date. And so you can do some very interesting things. You can say, put this into a collaborative filter. I have an icon for the generic tech company. That's no shade whatsoever on the generic tech company, but this company's solving some general problems for lots and lots of different retailers, or say lots and lots of different problem spaces. And so what I want to do is kind of walk through how when we have some fashion-specific data, we can do something that's maybe a little more relevant in the fashion domain. So for example, these could be cameras. We don't even know that these are clothes. So now let's actually dive into what this particular product looks like and see what that means. So let's say that this product is not just any product, but it's this particular shoe. For those of you who don't know, this is a shoe that's favored by Her Royal Highness, the Duchess of Sussex, Meghan Markle. It's a very specific shoe. It's not a shoe that you would go running in. It's, as we see, it's pretty expensive. It's got a 3-inch heel. It's made of suede, so we're not going to wear this in the rain. So now we have a lot of information about this particular shoe that we could leverage in, say, a recommendation algorithm or kind of learning from these transactions. So first I want to walk through a use case. So this is some research that we did with one of our retail clients to say, as we've seen a few examples where people want to know how to buy merchandise. And one of the big problems with merchandising in fashion is like how many of each size to order. And so one interesting thing that we found is because we have this attribute data and things like heel height and material and sleeve length and stretch and lots of other characteristics, we can start to learn how those individual attributes themselves play with popularity per size. So what I want to draw in on, so these are some knits and we're looking at sleeve length here. And if you look at the kind of differences, so in this case, blue is short sleeves, orange is sleeveless, and green is long sleeves, we see a big shift in kind of the relative popularity of short sleeves and sleeveless depending on the end of the size spectrum this is. And so the intuition here is that maybe people who have bigger arms are a little bit self-conscious about showing the upper part of their arm. And the reason this is important is if you only have style identifiers, then you might say just look at all shirts, or you might look at just this one particular shirt and you might see, oh, this was my size distribution for last year, so I want to kind of order those relative sizes, instead of saying, hey, if I do that, then maybe I'm not going to have enough styles with sleeves in the larger sizes, and maybe I'm not going to have enough with sleeveless in the smaller sizes. This is really important in a space like fashion where the identifiers in the particular products change every year. They change every month. And so it's important to kind of learn these bigger relationships when you want to be able to use this data even as the clothes themselves change and cycle in and out. Next, I want to talk about how we're leveraging computer vision and also our product attribute data to understand things about similarity. We've seen multiple use cases throughout today on this, and I want to tell you a little bit about what TrueFit's doing in this space. So again, we're picking on the generic tech company again, and I want to be clear, this is not, this is amazing what people are doing in this space. So this is an actual result that I pulled out online. One of the big tech companies, has this ability to look for similar images. And this is actually pretty amazing because all of these images are of people. They look very fashionable. They'll have, some similar colors and silhouettes, et cetera. And so this is a good result from a computer vision image similarity point of view. But from a clothing point of view, if you actually care about what those clothes are and you want similar clothes, it's not a great result. Like that handbag looks totally different. Some of these feature a long coat where the query image is a dress. And so even though there's something stylistically similar about the images themselves, the clothes themselves are not being keyed in on as much as they should be for a shopping application. So one thing that we did is we started from, okay, so maybe just the out-of-the-box computer vision isn't solving this problem. What does matter to people when they're shopping? What matters with how people perceive similarity? And I have, one of the data scientists on my team has a background in cognitive neuroscience, where for her PhD work, she conducted a lot of surveys and analyzed a lot of that data. So she said, well, why don't we actually design a survey to probe some of this? And so we conducted this on Amazon Mechanical Turk, people who are based in the US who are adult women who shop for dresses. And what we wanted, the way that this test worked is we had several images like this where the top dress is out of stock, and so we're forcing someone to choose which of these two is a better replacement. And the reason we're doing that is because in those two, we can vary some important characteristics to start to learn about relative importance of different attributes. So in this particular example, the dress on the left has very different sleeves. This is missing sleeves, where this dress has long sleeves. Here, both of these have a very similar floral patterns, similar color palette. This dress notice is much longer, but it has sleeves. And so if we keep doing this over many iterations or many variations of this test, and we ask lots of people, we start to learn what is the relative importance of these attributes. And something that I think is probably fairly intuitive, but think about when you're measuring distance between features. A lot of the algorithms we would choose don't learn, say, relative importance of features for that distance. And so certainly if we had just done something like Euclidean distance, we would weight everything equally. But what we learned is that length was far and away the most important thing, which was kind of interesting because we thought maybe color and pattern would be, and that's certainly what gets picked up in computer vision. But length is important, then color, then pattern, then sleeve length, and then a bunch of other attributes like button placement come way lower on the list. And so what we're then able to do is build an attribute-based similarity based on what we learned from this study. And this is, one of the things that's hard about something like attribute similarity is, say, that dress, the fourth dress in that's more like a blue-green color, actually has some red in it. So, does it have red? Yes. So it matches that red dress. Well, that's something that computer vision is really good at. And so here's an example computer vision result where maybe the coverage of the length of the sleeves and the dress length doesn't match as often. And so we're able to combine these two to get what we think is a superior result, where we're using the state-of-the-art computer vision neural networks, but then layering on what we know about individual attributes and the relative importance of them to hopefully provide a better recommendation for people who are shopping in what they perceive the similarity to be. So now I want to move into how we leverage our consumer preference data. So those are a couple of examples of how we leverage our product attribute data. So now this is exciting because we're going to look at how we know about shoppers and then how we leverage that to actually provide them with recommendations that are relative to them. So something that's kind of interesting that maybe you all have experienced too is that frequently people who work on brand teams, who design, who think about who their brand's customer is, often have an idea of a very specific person. And so when we think about the shoe that's $750, we think about, okay, this is someone who's very fancy, who has lots and lots of nice stuff. And what I think we as data scientists find every time we look at data is that the reality is way more complicated than that. And so what if you see that this is an actual user from our data set that I pulled out. I pulled out in part because it tells an interesting story. So sure, there are lots of people who buy the shoe who also buy lots of other nice things. But this is a shopper who's a little bit younger, who's actually shopped and expressed a preference for some very reasonably priced brands. So maybe this is a shopper who saved up and and caught a sale and bought an investment piece or bought something that she really cared about, but she doesn't necessarily have the budget to spend this level of money on everything. And so this is where it's really important to not just understand the products, but understand who these people are who are behind these transactions. And then we can start to learn some interesting relationships between the two. So first, I want to talk about how we built our style recommendation algorithm. So this particular chart, this was looking at a particular retailer's catalog. This is a season, or this particular assortment had predominantly calf length and thigh length dresses. And, certainly fashion blogs will say something about dressing appropriately at a particular age. And so we had this understanding that probably age did correlate in some way with how much skin was exposed. And so one thing we found is that while certainly not a binary relationship, we did see a trend that shoppers who were older tended to favor dresses that were a little longer than thigh length versus shoppers that were younger. And so that's something, when we put in all of our attributes and all these shopper characteristics, they're telling us how old they are and their height and their weight and things about their favorite brands. And we see some things that they've purchased before. So we get an idea of their preferences, and then we're able to learn how those relate to product attributes like dress length and sleeve length and colors in order to make some recommendations. One of the problems that we have to solve at TrueFit is we get a lot of shoppers who want to check out as a guest or who show up on our site for the first, or show up on our platform for the first time. And so we want to be able to make recommendations to them even if we don't know anything about their purchase history. And so this, by correlating with those attributes, enables us to make recommendations for them. However, let's say in this case we have a shopper who's a little bit older, who's a little bit heavier, and so maybe if we don't know anything about her, we recommend her some nice calf length dresses. But let's say that we do have a sales history so we can learn things about her preference. And let's say that she's bought a lot of things that don't have sleeves in the past and bought dresses that are a little bit on the shorter side. Well, then our recommendation algorithm is learning that that's a much better signal for what someone will buy in the future. And so as a result, she gets recommended some dresses that are a little shorter and that don't have sleeves. So finally, I want to talk about our size recommendation algorithm. So this has been, TrueFit has fit in the name, and solving problems in sizing and fit, the thing that we've worked on the longest. And one thing that we get asked is why we require, as part of our registration process, why we require shoppers to tell us about a brand and a size that they already wear. And so we did some data analysis with some data points that other people in the space frequently collect, height and weight in BMI. And we wanted to know, okay, how predictive is that? Because we believe strongly in learning about how you usually wear things versus what are your physical dimensions. And the reason that we do this, if you look at this vertical line, in this chart that shows BMI versus distribution of BMI over different sizes of US women's dresses, you see that for someone at a BMI of 24, they could very reasonably fit into, maybe they're a 2, a 4, a 6, an 8, a 10. Those are all pretty fat part of that distribution. And so it turns out that this by itself is not all that predictive of how someone actually wants to wear clothes. And so in this example, I pulled out 2 shopper profiles in our data set who've self-reported the same height and weight, which translates to the same BMI value. But one of them has told us that she generally wears a Gap size small, and the other one has told us that she generally wears a Lands' End size medium. Well, those are 2 very different sizes, and so that tells us, regardless of the physical dimensions of these 2 women, one of them prefers a much looser fit than the other. And so when both of them are looking at the same dress at H&M, which is one of the retailers that we work with, they get they actually get sizes that are 2 apart in the dress size system. And so this is how we provide size recommendations. So finally, so I really enjoyed showing you some of the work that my team's been working on and kind of the individual pieces. So in finishing up, I want to kind of put it all together and show you how we envision this shopping experience. So because we know something about preferences and we collect, people who register for our platform tell us a little bit of information about themselves, that would enable us to say, in the landing page, actually start out with items that we think are relevant to them, regardless of what their intent is for this particular shopping trip. So instead of the sifting through a million pages, maybe they already see items that are relevant. So then maybe this particular shopper sees this dress and says, yeah, I'm kind of looking for black dresses. Show me more of those. And so here we see, here are some similar styles based on what we know about which attributes are important for similarity in computer vision. Maybe it turns out that this particular shopper is looking for kind of a party dress, so she likes the one on the end. Well, then we can give her a customized fit recommendation to help her make that purchase, where we say not only what that size is, but about how it's going to fit relative to what she usually wears. So then this enables her to make that purchase with confidence. So I want to thank you all for your time and attention. The key takeaways: online shopping is hard. I know that's such a surprise to this group or to anyone who's ever shopped before. And we work with over 100 retailers, and we see that conversion rates are in the low single digits for all of them. So this indicates that people are having a hard time. They show up at retailer pages, yet they're not buying. They're having a hard time finding what they want. So we also know that there's a lot of technology that can address some shopping challenges, a lot of exciting work in using text and image data. And so there are a lot of tools to apply to this problem. And so we strongly believe that having data that's relevant to fashion and data across a diverse set of stores and a diverse set of people is important to power these machine learning algorithms in order to create great shopping experiences. So thank you very much. This is my contact information. Feel free to reach out to me. I'm actually hiring on my team, so if you're a data scientist looking for work, would love to talk to you and would love to answer some questions.
Thanks, Rhonda. So we do have a few questions. The first one, which had a plus emoji, was from Henry T., who wanted to know, how would you address that maybe for older customers, they may be buying for, say, their daughters, and that gets mixed in with their preferences. And there was a bit of a follow-up from Luke, who said, great question. I wonder if they could run net to identify far outliers purchases that are so far outside the predicted profiles that might suggest making them into a separate profile. Yeah,
that is a great question. That is certainly a problem, and I'm not going to claim that we've 100% solved it. So it is hard. Sometimes it can be hard to identify items that someone's purchasing for someone else. And so one thing we do, again, since our DNA is all in size and fit, one thing we can do is certainly if we see some really different sizes in someone's profile, that enables us to flag and do some outlier filtering or detect, say, this is someone who has an Etsy shop or an eBay store and they're just buying all the sizes of this particular item and it's not even a real person versus there are clearly two distinct people in this. But if those sizes are close enough, then it becomes just an inherently difficult problem. And it's certainly, that kind of behavior, I think, can really impact machine learning recommendation algorithms. So I don't want to gloss over how hard that problem is.
Yeah, it sort of sounds like that. The next question, I'm going to ask one from, I'm going to ask one from Hui Yang instead. I should point out that although you can add emojis to your own questions, those aren't considered in deciding which questions to add first. However, this person did get a thumbs up from 1 or 2 people. How is the computer vision signal and attribute signal combined?
That's a great question. Right now, so the first approach that we've taken to do that is that we find that it's much more efficient to select items that have similar attributes. So we start with items that are similar in attribute space, and we'll then reorder them based on their computer vision similarity. But there's a lot of opportunity to do something more intelligent in that space.
That was Rhonda Textor, head of data science at TrueFit, sharing insights that TrueFit has gained from their fashion genome. She showed how they leverage their large data sets and cutting-edge technology to enable personalized shopping experiences, and how they combine fashion and technology to make the best recommendations possible for consumers. If you'd like to watch more videos like this, you can subscribe to the DSS Insider program, where you can see our complete on-demand video repository from a wide range of topics. Subscribe now following the link in the video description below. Thank you!